Hello everyone, this is VVS Stream. In this video we are going to see how to vary the intensity of the light using a potentiometer. These are the components required for the project. I have an Arduino UNO, a breadboard, a cable, UNO cable, and a resistor of 1 kilo ohm resistor, an LED of 3.3 volt, and few jumper wires. And this is called as potentiometer. Take a closer look. It consists of 3 pins, the first pin, second pin and third pin. The first pin is positive and the third pin is negative and the center pin is the signal. We can vary the potentiometer by varying the screw given here. You can see that the knob moves. By varying the knob, the resistance of the potentiometer is varied. This is used to vary the resistance and give output as a signal. So now let's get into the circuit. In order to connect, I am using the jumper wire. So the positive of the potentiometer is given to the positive terminal, and the signal wire is black, and the black signal wire is given in the center. So I have connected all the parts of the potentiometer. Now I should connect the LED and positive negative for the potentiometers. Now let us select the pulse width modulation. This pulse width modulation is used to vary the analog signal given as the input or output. A pulse width modulation deferred with normal output gives stepped output. That means an analog value from 0 to 255 can be given in the pulse width modulation, but using digital pins we cannot do that. So see here, it is mentioned as digital PWM, digital pins, and PWM with the approximate symbol 11, 10, 9, 6, 5, 3 are the pulse width modulation pins. If we give input from the other pins, these value does not respond. They respond as 0 or 5. But if we give input from this pulse width modulation, a varying signal, that means intensity of the light or intensity of the signal is varied from 0 to 5 volt, 0, 1, 2, 3, 4, 5, likewise. So I am connecting the pin number 9 and ground. So now I have connected the pin to the breadboard. Now I should connect the LED and the resistor. The positive terminal of the LED is connected to a resistor and the resistor's another end is connected to the 9th pin. You can see that the right part, the lengthiest part is the positive terminal of the LED and the smallest part is the negative terminal of the LED. So I am connecting the positive to the another end of the resistor and negative directly to the ground. So now the circuit has been completed and potentiometer is connected with positive negative and the black terminal is the signal. The signal is connected to the A0 pin here shown here. Let's enter into the coding part. As we mentioned before, the circuit consists of 4 pins connected to the Arduino. One is of ground pin, another one is of 9th pin, another one is of A0 pin, and another 5 volt pin is connected. So the 5 volt pin does not need any programming to be done, but the 9 volt pin and the A0 pin to be done as programmed. So as mentioned in the previous video, we should use pin mode. This pin mode sets the pin to be input or output based upon our requirement. Arduino IDE is case sensitive so that the spellings are more important. If we give small m instead of capital M, it may raise an error. So pin mode, and the pin we require to use as input A0. The A0 is analog 0 So analog 0 gives the input from the sensor as analog values, not high or low, but 0 to 1024. So the values varies from 0 to 3, 4, 5, 6, like that goes on until 1024. These values can be measured using A0. So we should use analog 0 as input and the ninth pin as output. As A0 is used as input, the input consists of 0 to 1023, but the ninth pin is set as output. It may be of digital or analog. Previous videos I have mentioned about digital and analog read. If you do not know what is digital and analog, please see the previous video from my channel. I have now set up two pins, A0 for input and 9 for output. 9 is used to glow the LED and A0 is used to take the reading from the sensor. Now I have set the pin. The next process is to be done to get the reading from the sensor. In order to get the reading from the sensor, we have to read the input. So analog read is used. If you use digital read, the value given as an output is only of high or low. If we get analog, the value is from 0 to 1023. That's the only difference between digital and analog. Analog read of A0. So analog read of A0 gives the value present in A0, which is given as a signal into the microcontroller. But we have to store this value into some variable. So I'm using this as value, a variable named value. The type of the value is maybe of integer, double, float or string. We must mention it before we initialize the setup. Now we must need another value which may set up later. So value is equal to analog read of 0. All the values from the analog read is printed. If we want to print the value of analog read, we can use serial.print. This serial.print prints all the values from the serial monitor. In order to work serial monitor, we must begin it serial.begin with baud rate of 9600. This baud rate may vary according to the usage. Several baud rate increase in the baud rate uses the higher frequency like Bluetooth and Wi-Fi modules. Normally we use 9600 as baud rate. The A0 value is stored in variable value. So I am printing value. After printing serial.print value, now I have connected the pins circuit. I should connect it to the PC. Now I want to upload the program. I am uploading it. First I must select the serial port. It is selected. So I am saving it. Now the program has been compiled and it's uploading. See, now it's uploaded. So I must open the serial monitor. It is in the top right corner with the search symbol. I have connected it to the PC. Now it is the potentiometer. I am setting the value to minimum. So I am opening the serial monitor. Now the value is given 0. Notice the knob. It is in the top right corner. A black dot is given. So I am trying to twisting it. As I twist, the value increasing. It's now 200. I twist a little bit faster. It's 300, 400, and now it's 647 to 8 varying. So the value of the potentiometer is obtained from varying the resistance of the potentiometer given inside the knob. So the positive and negative terminal consist of 5 volt. By varying the potentiometer, it gives only of 0, 1, 2, 3 or 4 based upon our requirement. As by adjusting the potentiometer knob, a output signal is given and the signal is given to the A0 pin of the microcontroller, which is processed inside the microcontroller and brought as the required output for us. So it is the maximum value 1023, see 680, 237, 757, 984, 189 and 0. So this is the minimum and this is the maximum. We can we can do a program by combining the previous video and the today's video. So let's do it. First we need the analog input as we acquired. Now I am going to print the value into the analog write to the 9th pin. So while using analog write, we cannot give 9, high or low. We must specify the value to be printed. So analog write value varies from 0 to 255 only. If we give the value mentioned, if we give the value that we acquired from the analog read of A0, the value may get high, the LED may get burned. So I am dividing it the value divided by 4. So I should make the value res is mentioned as result. Res is of result integer type. So I am mentioning it. Now I should give the value of res to here. That's all. The program is completed. So the value is read from the analog read and stored and printed, and then res is equal to value by 4. That means 1024 divided by 4 gives 255 around at a rough, and analog write of 9, res prints the value of res into the analog. So if I do this, we can vary the and get the output. I am bringing the value to the lowest level first. Okay, it is in the lowest level. So let's make the LED visible. Okay, now I should upload it. Say uploading, compiling. It's uploading. Now it's uploaded. Okay, I open the serial monitor again. You can see the values and potentiometer movement from this video. You can see that this is the potentiometer, Arduino, and the LED. Make sure the LED is visible. Okay, there is a point right top of the potentiometer. Notice that, and also the values mentioned in the serial monitor. So the value is now 0. I am increasing it to 10. So it's 20 now. Okay, at 10 it's of bit lighter, and I am increasing it to 50. In 50 it's light brighter than the 10, so I am increasing it to the 100. Obtaining input from the microcontroller using sensors and giving it as an output to the something, an LED or motor or a fan. So now we have completed the session. It's look awesome. So thank you for watching my video. For more videos, subscribe to my channel. Thank you.